Okay, so let's have a look at Lewis structures. So for Lewis structures, there are a few things that you need to remember. And the first thing that you are going to have to remember is that for any Lewis structure, you have to keep in mind the octet rule. Okay, so the octet rule says that each one of the elements, with the exception of hydrogen, wants to have 8 valence electrons. What is a valence electron? A valence electron is how many electrons are on the outer shell. So how many on the outside? And you can read them from the group. So if it is a group 1, it will have 1 valence electron. Group 2 will have 2. Transition elements are all 2. Then for group 3, that will be 3 electrons, 4 electrons, 5 electrons, 6, 7. And then of course the noble gases all have 8 electrons. That's why they're mostly, not always, but mostly unreactive. So we also know about valence electrons. So valence electrons is related to the group number. Okay, so let's say you are faced with a structure. Let's say you have something like calcium chloride. Okay, so the first thing that you are going to do is you are going to need a periodic table. So let me just quickly open up a periodic table here. And for the periodic table, what you're going to do is you're going to look, where is this element? Okay, so when you look at this, I'm going to show you quickly there. So there is my periodic table. Okay, and I'm going to look for calcium. Calcium is in group 2, right over there. So group 2. So we know that for calcium, the amount of valence electrons will be 2 valence electrons. Chlor is in the 7th group, right there. You can see chlorine. So chlorine is in group 7, main group 7 or 17 on this table. Okay, so for this one, we'll have 7 electrons. Okay, so what does this mean for us? With Lewis structures, this is actually quite a bad example because for this one, what we have really is an ionic bond. Lewis structures only really work for covalent bonds. But I want to show you that the idea is the same. What's going to happen is calcium is going to be 2 positive and chlorine is 1 negative. So what we know is that if we want to bind them together, what I need is I'm going to need 2 chlorine ions for every 1 calcium. Because remember, overall, if I put them together, I'm going to need 2 chlorine, so this will be a 1 negative and a 1 negative, and of course this will be my 2 positive, right? And that's balancing your molecule so that overall you have a neutral molecule. Whenever you write down a molecule, it must always be neutral. You can't have things in ions. If they are in ion form, it means you are working with redox. Remember, reduction oxidation reactions. Okay, so let's try one where we are actually using, because for this one what we see is that when I have the calcium is going to take 2 electrons and it's going to give them away to become 2 positive. So calcium is going to become 2 positive, and there's going to be a chlorine on this side and maybe a chlorine on this side, and they are going to take 1 electron is going to go to the chlorine, and 1 electron is going to go to the chlorine on this side, making it 1 negative, 1 negative, and overall we have a 0 charge. Still the octet rule, what I'm trying to show you here is the octet rule. Still the octet rule applies. Now calcium is going to have 0 valence electrons, and each of the chlorines is going to have 8 valence electrons. Now what happens if I have a compound that bonds with organic covalent bonding? What will happen there? So let's have a look. If I take a compound, for example, I take something like, just hold on,